Hey, welcome to 2.3 example B, and it says the data used in this histogram have a mean of 34.05 and a standard deviation of 14.68. So approximate the percentile rank of a value 2 standard deviations above the mean. Okay, so we have to really look at what does that word percentile, or that phrase percentile rank, mean. And you've probably heard it a lot before. They say you're in the 40th percentile, the 50th percentile, the 90th percentile, the 10th percentile. And really, what does that mean? All that it means is that you say, look at all the data values and figure out of how many, where are you if you kind of rank them, right? So this would be the lowest to the highest. And you say, what percent of the data is below you? All right, that's really what percentile rank is. What percent of the data is below you? So we can say percentile rank. A good way of thinking about that is what percent of the data is below a value. All right, so let's look at the first one. Approximate the percentile rank of a value 2 standard deviations above the mean. All right, so let's do part A. And 2 standard deviations above the mean, so that means we're going to take 34.05, and we're going to add 2 standard deviations, which are 14.68. All right, so let's quickly calculate that. So let's go ahead. Oh, I need the right one here. There we go. Okay, so it was, let's go back here real quick, 34.05, 34.05. Oh, it's not going to let me do it. Okay, 34.05 plus 2 times, and it was 14.68. 14.68. We hit enter, and we get a number of 63.41. So we're looking for a number that is 63.41. All right, so we look at these and we say, where are we? Well, I know it's between 60 and 70, right? And actually, each one of these goes up by 5. So it's in this one right here. We're looking at that one right there. All right, so we don't know which one it is, but we can say everything that is below the 61 right in there is going to be helpful. All right, so I'm just going to get rid of those lines so we can count. And so we would need to figure out how many of these are there. So I'm going to write below here because there's not a lot of room. So how many are in the 10 to 15? We've got 2. How many are in the 15 to 20? There are 4. How many in the 20 to 25? There are 5. How many in the 25 to 30? There are, looks to be 9. All right, and how many are here? We've got a 4 and a 4. So we've got a 4 and a 4. The next ones are 3 and 3. And then we've got a 2, a 1, a 2, and then a 0 and a 1. All right, so these are all the numbers. So if we add all those together, 2 plus 4 is 6, plus 5 is 11, plus 9 is 20, 24, 28, 31, 34, 36, 37, and 3 more is a total of 40. So we can say there are a total of 40 data points, right? So we have a total of 40 data points. And if we look at this, how many are below this one? Well, we know our answer for the percentile rank is going to be something out of 40. And how many are below us? Well, we have 1, 2, and 3, right? The last ones are the ones that are not below our number. We don't know exactly, so we have to say, well, it's in between those, so it might be the top one, it might not, but we're not sure which one it is. So we're going to say that this one for sure, and these two are not necessarily below it, so we're going to say anything from 60 to the right, which means we're going to take 40 minus the 3 and gives us 37 of our data points. So if we say, what percent is that? Let's take 37 divided by 40. So 37 divided by 40. And you end up with 0.925. So then the percentile rank would be 92.5%. All right, and then let's do example B. Approximately what percentage of the data values are within 1 standard deviation of the mean? Okay, so that means within 1, that means it's going to be 1 above or 1 below. So we really want to have it be 34.05 minus 14.68. and we want it to be in between that number and, let's just give it an x, let's put our variable, and 34.05 plus 14.68. Alright, so let's just add those together real quick. 34.05 minus 14.68. Alright, that number, and we have, actually, you know what, I'm going to delete that. I'm going to clear that one out. We're going to go here, we're going to go up one more. I'm going to hit enter, and then that way I don't have to redo all of them. Just go back to the minus and put a plus. So that means it's going to be between 19.37 and 48.73. So we want to have 19.37 is going to be less than or equal to our percentage, and less than or equal to 48.73. Alright, so I want to have my numbers in between here. So that means it's got to be between 19, so that means I'm looking at this one right here, and 48.53, so it's got to be within right there. Alright, so we're looking at those two within that spot. That's where I'm looking. So let's count up how many do we have. Well, it's not the 2, so it's not that one, and it's nothing above this one. So the 2, the 1, and the 2. So I'm not including these. I'm not including those. So it's only the ones that I now have underlined that I need to add together. And if we're talking about percentile rank, I know this number has to be, oops, wrong way. Let's just make that a little bit smaller. I know my number has to be out of 40. Alright, so I have 4 plus 5 is 9, plus 9 is 18, 22, 26, and 6 more makes it 32. Let's just see if that's right by subtracting from 40 minus these. 40 minus 2 is 38, 36, 34, minus 2 more is 32. So we're left with 32 out of 40, and that gives me a percentile rank of 32 divided by 40. I hit enter, and I get 0.8, which gives me a percentile rank. We're just going to say this, 0.8. So my percentile rank for this problem is 80%. I guess maybe it's not percentile rank. It says what percentage of the data. So it's not percentile rank. We're going to say 80%. There we go. So 80% of our data fits within that area, within one standard deviation of our mean. All right, there you go. There is example B.